Right, guys. So this is the second method, and it's very, very important, especially for grade 10. The table, yes, you can use, but this is very important. This is what's required. So what does the dual intercept method say? It says that if we want our x value for our x-intercept, do you see that? If we want our x-intercept, we need to let y equal to 0. And the reason why it's saying this, if we want the x, we have to let y 0, because we cannot solve these two variables at the same time. Hence, we have to let one of them equal to 0. This is the rule, and this is what it states. Right, so if we want the x-intercept, we let y equal to 0. So in the place of y, we're going to put 0 equal to 2x plus 1. Right, now we need to solve for x. So I'm going to transpose this positive 1 to the other side. I hope you know how to solve for x, Shem, because at this point, then we have 2x. But we're solving for x, so we're going to divide by 2 on both sides. Why did I divide by negative? 2 on both sides. So this 2 will cancel, leaving us with x. So x is equal to negative a half. Now, how do we write this? Remember, I showed you how to write intercepts. So for x-intercept, we're going to write negative. Right, so we're still talking about the gradient. I'm going to write an equation here, and then I want to explain. Let's say we have 2x plus 1. Right, so do you see that the m would represent the 2? So meaning the 2 is the slope. Now the slope tells us the direction. If the graph is in this direction, or if it's going to be in this direction. Right, now you see the 2 is positive. When your gradient is positive, it means that it's going to be in this direction. And if your gradient is like this, then it's going to be a negative number. Meaning if you have y is equal to negative 2x plus c, your graph is going to look like this because the gradient is negative. So you need to be very, very careful when it comes to these numbers in front of the x, which is your gradient. We talk about the direction of the straight line. And I'll talk about the steepness you'll see in terms of the drawing. Right, so the gradient also talks about the direction of the straight line. Right, now we get to this plus 1. Now this plus 1, it means that our y-intercept is going to cut at 1 on the y-axis. Right, now we need to plot this graph, and I want to show you the second method. The first one we did with the table. Now the second one we're going to do with a dual intercept method. Right, so let's talk about a straight line. So as you know that everything has its own anatomy, like a human body has hands, it has everything that's operating. Even a straight line, more or less, it also has an anatomy. Right, so we start with the equation of a straight line. So an equation of a straight line can be written in this way, can be interpreted in this way. Right, it says y is equal to mx plus c. Right, you see we have a lot of variables here, but when we start working the straight line, you'll understand what each one means. Right, now let's look at this m in front of the x. So this is what we call a gradient or a gradient. I don't know how you want to say it, but it's a gradient. It's a gradient. Yes, you choose your struggle. Right, so what is a gradient? Right, let's say this is a road. You see that road that takes you to office, and then before you get to office, man, this road gets like this, and then it starts moving, and then eventually it becomes like that. Right, so this is you and this is your car, and you are traveling to office. So of course now as you travel, you see, man, yeah, this road is getting very steeper. You must know your accelerators and your brakes. Hey, this car can roll. If you don't know your learners, you'll fail. Right, so as you drive now, this road gets very steep. Do you see that? Yes, it gets very steep, meaning yeah, you lose it's going up, and then as it goes down, the steep starts decreasing, and then as it decreases, then it becomes normal. Do you see that? Right, so gradient would be the steepness, meaning this is the steepness of a line. Do you see that? And this is also steepness, but now it's in this direction. If you come in this way, it's going to be up there, but if you go in this way, it's going to be down there. So this is what we call the steepness. Yes, so that's the gradient. Right, so if I was to draw these straight lines like this, we have this straight line, we have this straight line, and then we have this straight line. Now looking at these straight lines, can you see that this one is more steeper than this one? Yes, and this one is less steeper. So the steeper, the higher you go, the more steeper it gets, and the lower you go, the less steeper it gets. So when we talk about the gradient, we talk about how steep the line is. So it tells us about the steepness, or it tells us about the slope. So slope and steepness is the same thing. Right, this is the gradient. Now let's focus on the letter C. Now the letter C, we call it the y-intercept. This is a point at the y-intercept. This is not how you write intercept, but oh, the English is going. Intercept. Yes, the y-intercept. This is where the straight line cuts at the y-axis. Straight line where it cuts at the y-axis. That's the only thing that you need to know about the straight line. The gradient of the straight line and the y-intercept. The x and y, you used to them. These are the new variables that you're not used to, but now you'll see what happens. Right, guys, so we're looking at the x-intercept. Apologies. So when x is equal to a half, then y is equal to 0, because we let y equal to 0 for us to get the x-intercept. So meaning this is our point. Right, we're going to do the same for y. So we're going to say for y-intercept, we must let what equal to 0, our x. So we're going to let x equal to 0 so that we can get our y-intercept. So in the place of x, now equation was like this. In the place of x, we're going to put 0 so that we can get our y. Now, if we are going to multiply 0 with 2, we're going to get 0 plus 1. So y is equal to positive 1. Right, how do we write our intercept? We start with x. So our x is 0 and our y is 1. You only need 2 points to plot a straight line, and this is how you find your points. So we're not going to use the table method a lot. We only use it when we're really struggling, but for now this is how it's going to work. You're going to use the dual intercept method. You're going to perform the process of letting x-intercept equal to, not x-intercept, letting y equals to 0 to find the x-intercept, and letting x equals to 0 to find the y-intercept. This is how you do it. Now we're going to plot it. As you can see, I do not have a lot of space, so I shall draw my Cartesian plane here. Right. So this is our 0. You know the 0 is in the middle. Then we're going to have 1, 2. I'm only going to count till that negative 1 is, then 1, then positive 2, Then here we're going to have -1, -2, and we're going to have 1 and 2. Guys, I'm not plotting a lot of points because I can already see that I have a half and I have 1. Right, let's start here. For x value that is negative, we have negative a half. Now let's look at negative half. This is 0 and this is -1. So if we wanted negative a half, it would probably be here, ne? So meaning our point can be here. Right, so for x we want a half and it's here, and they're saying y must be 0, but you can't say 0 is here. It's not here, it's exactly on the line. So meaning our point here is negative a half and 0. That's our point. Our second point says on the x-intercept we must be at 0, but on the y we must be at 1. So on the x we must be at 0, but on the y we must be at 1. So this is our second point. Now we connect our 2 points together and we draw our straight line. Now I want to show you something. Remember, I said that this one is the y-intercept, where it touches or it crosses the y-axis. Now look at this line where it cuts on the y-axis. It is cutting at +1, and therefore that is what this one means. So this one is cutting on the y-axis at this point, which is 1. Right, let's say our equation was actually negative. Let's make it -3x and +2. For example, this is our equation of the straight line, and we are asked to plot it using the dual-intercept method. Remember, the dual-intercept method says if you want your x-intercept, you let your y equal to 0. If you want your y-intercept, you let your x equal to 0. So we need to plot this straight line. Now let's start. For our x-intercept, we let y equals to 0. So in the place of y, we're going to put 0, and we're going to try and solve for x because we want the x-intercept. We cannot solve x and y at the same time. So let's transpose the +2 to the other side, which is going to become -2. Then we have -3 this side, but because we want x, we're going to divide both sides by -3. So we divide x by -3. Now x is equal to positive, because negative divided by negative is positive, so it's going to be 2/3. But please don't write it as a fraction. Don't write it as a decimal. Yeah, we prefer it in a fraction form. You can try and find the decimal of this and then you can plot it, but it's fine. Right, let your x equal to 0 for your y-intercept, meaning in the place of x, we're going to put 0. Now in -3 multiplied by 0 plus 2. Right, so when we multiply this, we get 0, so it's 0 plus 2. Our y-intercept is equal to 2. Now we need to write our points. For the x, we're going to write 0 is 2, and for our other point, it's going to be 2/3 and 0. Right, now we need to plot this straight line using these 2 points. Right, now this is my straight line. Right, so let's plot this point. Now 2/3, when you put it in the calculator, it gives you 0.6666666. Yes, but you can write this as 0.6. Now let's go look for 0.6 on the positive side. If this is 0, 0.5 is here, so 0.6 is probably somewhere here. So for our x point, our first point, it's going to be 0.66, and for our y, it's going to be 0. So either way, it's still on the line. All right, the second one, or you can round it off, guys. You can write it as 0.7. See, it's not that bad. Right, let's get to this one where we have 0 and 2. So at 0, then we go to this one. So you see what is happening here, you guys. It's very hard to draw a straight line without a ruler. Ooh, my straight line is so ugly. Yeah, but I know you can draw it better. Now look at the line, look at the gradient. Do you see where the gradient is going? It's going this direction, meaning it's negative. And how would you find out? From your equation, look at this gradient. It's a negative gradient, hence our line is moving in that direction. And with this point, this +2, it means that our graph is cutting here at +2 on the y-axis. Yes, and this is how you draw a straight line.